All right. So for 31, I did tell you the trick for graphing vertical lines. Make sure you have that on your study sheet if you because you just have to have it somewhere if you want to remember. When you're trying to graph, just make sure you find your intercepts. This would be x is equal to 2, 2, 0. You're gonna love these ones when the coefficients for x and y are the same. It's very easy to find the intercepts, right? Because the other one turns 0, and you're just left with x is equal to 2. In this case, x is turning to 0, so y is equal to 2. Rewrite it real quick. Y is greater than or equal to negative x plus 2. And we have solid. True region is above, right? And we're going to shade below because it's a system. That's the main reason why we're going to shade reverse. Okay? Okay, beautiful. Now this one. Special case. It's a vertical. Goes through 4, 0. It's going to be dashed. The true region is, what do you think? Fine, don't talk to me, that's fine. Shade right. Okay, now graph it. So this one is actually not too bad. This one shouldn't take you that long. So if you've copied that, I'm going to the graph now. I would encourage you, I know this one works out just fine. Okay, this one works out just fine, but I would encourage you to first graph it. I need to be careful. This one is set to radians. That's next year for you guys. So just type in the rewritten. And this one is the 999, right? This would be x what? Minus 4, yeah. There we go, perfect. That's what it looks like. Look at my window, zoom 6, right? It's a standard window. A 10 by 10 will be just fine in this case. Be careful what's down the road. You're gonna maybe have tens or hundreds or thousands. And so you're gonna have to adjust your scale to make that happen. That's why I'd say graph this first, see if it works. X, Y, 2, 0, 0, 2. Does it make sense for this line to be going down? A little quieter now, okay? You're talking math? Okay, just a little quieter. Negative 2, yes, it makes sense for it to go down, and it's solid, right? This is y is greater than or equal to negative x plus 2. And then the vertical goes through 4 right here. It's dashed. X is less than 4. And we're shading to the right here. And we're shading below on this one. Label your solution region, especially because we're using reverse shading. Oops, you can't see that. Now you can. Okay, to the right of this, below this, this is your solution region. Find the corner point. Right, we go second trace 5. We only have 2 lines, so we technically don't even need to get close to it. 4, negative 2. So you can either label it here, or you can state it over here. It doesn't matter. As long as I see that, so you understand which one the corner point is. Is negative 720 a solution to the system? You should check, right? You have to check. I don't know if it was on the key. So let's do that real quick. We plug that into this one. This is negative 7 plus 20. So this will be 13. Is that true? Yes. And then the next one is x is less than 4. You plug in x, and this is also true. So negative 720 is a solution. And I mentioned that before, but if you do the first check and it's false, done. You stop doing that. Like, don't keep going through all the other inequalities, because as soon as it's false for one of them, it's not going to be a point for the system that we can use. Let's do the trickier one on 32. That's the one that it's actually not bad at all, but we need to know how to deal with those cases. So go to 32, and this one is the way we want it. So x is equal to 6, 6, 0. And then this one is 2y is equal to 6, y is equal to 3, 0, 3. Rewrite it. Divide everything by 2. Do we need to flip it? We don't, because it's not a negative. So it's negative 1/2 x plus, don't forget to divide this back part as well. That's the rewritten form. This is dashed. True is below. I shade above. So down the road, my key probably only has these 3 letters, right? I don't even write it out anymore, because at this point we know what. If you don't want to have the D there, maybe have one of these, like a dashed line. It's just a code for us to know what to do when it's graphing time. Now this one. So I will say this, no constant. And if you looked at the key, you probably saw this. Right? There's no constant, so you have to deal with it in a different way. And I might do it slightly differently than what my key was showing. So what does this mean? It means that it will go through the origin. There's nothing we can do about that, which means that the x-intercept is exactly the same as the y-intercept, which is 0, 0. Okay, so that is the problem. Because if you connect 0, 0 with 0, 0, you don't have a line, right? It just stays where it is. So don't even bother doing this part here. You have to have a different approach to it. I'm going to flip this, okay? I'm going to bring this over to that side and this over to that side, because I want the y over on this side. So when the y comes over, it's negative. When the x comes over, it's negative as well. So they kind of both switch signs because they're both going over the inequality. Then I need to divide both sides by negative 1. What happens at that point? Right? It flips. Oops. It flips. So this way. So that's x, right? So this is what you want. This is the rewritten form, and this would be dashed. True is above. We shade below. So that part is still there. So what I do is 0, 0 is the first point. Okay, we're going to have that on our graph for sure. Find second point. This is the trickier part right here. You have to find a second point somehow. And I base this on what's already happening. Look at this. The values for my other line, they're small values. Okay, they're like 6 and 3. So I will let x be equal to 5, let's say. So basically, what is if you put 5 in there, what is 5? What is the point that you just found? When x is equal to 5, y is equal to 5, right? You're putting this 5 in there. So when this is 5, you're also saying that y is going to be equal to 5, right? If you're looking at the boundary line. So therefore, second point is 5, 5. So this is your second point that we're going to use to graph this thing. Mr. Dirksen, what if I had used 3, 3, or just 3? For sure, then your second point would have been 3, 3. If you used 100, your second point would have been 100, 100. The point is you just need another point to be able to make that line. Okay, so let's go ahead and do that. Let's graph both of them. So x and y axis, don't forget about that. So 5, 5 is here, and 0, 0 is right there. So I'm actually graphing the second line first. It's a dashed line. This is going to be the line y is greater than x. And then I'm graphing the other one, 6, 0, 0, 3. And that's also a dashed line. It's not a word problem, so you just extend, right? I'm just going to use this one. So we're shading above above that. What happened here? This doesn't look like a dashed line. Okay. Above this line, so we're shading there. And we're shading below this one. This is my solution region. And my corner point is right here, which I'm going to find using my calculator. I just want to say one thing here. This is going to be a nightmare for me to mark, and I have decimals on 24/7 for this one. Let's say go up here where my pencil is. You forgot to flip the sign. Okay? You did not flip the sign. You would have actually been shading the exact opposite, right? You would have been shading above. So when it comes to this this line here, you would have shaded this top part. So for you, the solution region would have been right here. So you're not going to lose marks on the graph, but you will lose marks up here if you make mistakes. Okay, so just be careful when you do that. Another thing to check: what is my slope for this line right here where my pencil is? Slope is 1. Okay, 1 over 1. So let's check that. If you go to 0, if we go to 0, 0, if we do 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, do we land at that 5, 5 we found? 1, 1, 1, 1. That keeps going 1 to 1. Okay, so that's another thing to check. What's my B value here for this one? What's the y-intercept? It is 0. Okay, it is actually 0. So there's technically a plus 0 here behind it, but we just don't bother writing it down. Okay. Let's find a point of intersection. I think it's 2, 2 based on that, but sometimes the graph is deceiving. So I'm just going to type that in real quick. Negative 1/2 x plus 3, and then x there. I think I'm also going to give you a heads up on cases like these. 2, 2 is the corner point. That's usually worth a mark. If you have to use your calculator to go get the corner point, I give you a full mark for it. Is negative 12, 7 going to be a solution, you think? I think visually we can tell yes. Right? Negative 12, it would be, this is 10, this is 12. 7 is right there. I can tell that that's going to be part of my solution. Right? So I'm not going to show you right now how to do it. That's for you to try. My key, I'm just going to show you the key. Both of them end up being true. I plug this point into the first inequality, the second inequality, Both of them turn out to be true, so it is a solution to the system. Question. You awake? Yeah? Is 2, 2 a solution to the system? Why not? A bit louder. It's touching the line, and it's a dashed line. Yeah. It's on the lines, it's on both lines, and they're both dashed, so it's a no-go. Even if one of them had been solid, but the other one dashed, you still can't use it for the system, right? Because one of them is saying, I'm dashed, I can't, like nothing on the line is working for this particular inequality. Okay, there you go, you are awake. Okay, so I'm gonna give you a heads up on this, okay? So I'm gonna make a note here, somewhere right here, just a note. Right there. Example, what if you had something like this? You rewrite it, and you have, there's no constant again, so first point will be 0, 0. Okay. Second point, what should you let x be in this case? What would be a smart choice for x? Pick 4, because if you have 4 here, it's going to cancel out this 4 over there. Let x be 4, and then you have y is equal to a quarter times 4. These cancel out, right? So you end up with 1. So what would be the coordinate of my second point in this case? X is equal to 4, y is equal to 1. And right now, if this is kind of, if it's not sticking yet, you might have to come back to this down the road. Whenever you get a fraction, pick a value for x that allows you to cancel out that denominator. Okay. All right. We're going to go to, I'm going to skip a few pages here. We're going to try 3 inequalities at a time. So we're going to go to 36. And I know it sounds backwards, but we're going to do 36 and then 36 and then try 37. We're going to leave 35 for now. Okay. So 3 inequalities. You're going to do each one of them individually. You're going to do the intercepts. You're going to rewrite it. You're going to tell me where to shade, whether it's solid or not. And before you start graphing, we're first going to stop here and first check, making sure we all did that work right. And then I want you to go ahead and graph it, okay? So take a little bit of time. I'm going to put a timer on. Let's see how, I'm going to try to do 5. So you just make sure you verify, okay? So this would be 8x is equal to 25. X is equal to, am I doing this right? Right page? Yeah, 313. It's okay to round here, because this is for graphing purposes. Then it's -5, y is equal to 25. We divide by 5, y is equal to -5, so 0, -5. Okay, clean that up. And you rewrite -5, y is less than, or just less than, -8x plus 25. We divide everything by -5, flip the sign right away. That's 8 over 5x minus 5. Dashed, true is above, shade below. Okay, next, -2x is equal to 15. Divide both sides by -2. X is equal to -7.5. So -7.5, 0. Then it's -3y is equal to 15. y is equal to -5, 0, -5. So it's going to be an overlap here, right? -3y is less than or equal to 2x plus 15, because the 2x comes over, adding. Divide by -3. Y is, flip it right away, flip it. -2 over 3x, -5. Solid, true is above, shade below. And notice that they're opening the same way, so you would expect that to be consistent, right? Next, this will be, we need to do some cleanup, right? Should have a Barney song here, cleanup. So this is, I'm going to bring the x over here. This x comes over, subtracting, plus 2y. And on the other side, I have the 3. Okay, so this cancels out. So you left, oh, what's that? That's a horizontal line, isn't it? Nice. Y is, sorry, 3 over 2. So I keep this. I know 1.5 is fine, but because this is going to go into my calculator, so I try to just keep it that way. So this would be solid. True is above. We shade below. It's a horizontal line, right? Horizontal line. At 0, 1.5. Okay? Now go ahead and graph it. And find the, type this into y1, y2, y3. See what it looks like on your graph and on your screen, and then transfer it over to this grid right here with shading and everything. Okay? Pay attention. This is your only example probably that I'm going to do for 3, because then I'm moving on to word problems. So you graph it on your calculator first and see if your window works. This is still my standard window, so 10 by 10 will do just fine. This one is a little bit on the verge, but it still works, because you want to see where they all meet, right? So 313 is right about there. 0, -5 is there. Okay, that's a dashed line. So you should have that one. Okay, so ideally I did 5 minutes and 5 minutes, so 10 minutes. If you can get it to that point, you're doing pretty good. And this one is -7.5. 0, -5. It's right here. Does it make sense? Yes, because the slope is negative. It should be dropping. This is a solid line. Okay? And then you have your horizontal going through 1.5, going right there. It is solid as well. Okay? This is y is greater than or equal to 3 over 2. All right, now the shading part. The first line, this one, I shade below. Okay, so shade below. Then you shade below as well for this one. So that's all gone. What about the last one is also shade below. So you go to your horizontal, this one, and you shade below that one. So this is your solution region. Okay. Question. Make sure you pay, what are your corner points in this case? It's where the boundary lines meet surrounding your solution region. So this is your solution region. So the boundary lines meet right here. So this is corner point number 1, and you're going to have another one right here. So this is POI and POI, right? There's only 2. This one down here where the 2 diagonals meet is not surrounding your solution region, so we don't count that one. Okay? So let's go ahead and find those. I'm going to attempt to just leave everything as is. So I'm going to find this one here between the black and the red, second trace 5. I'm going to jump to the black line maybe, yep, and just go a bit closer to that one. Hit enter, and then I'm going to cycle with arrows up. I'm going to cycle to the red one, and then just keep hitting enter until you get the coordinate. So that's negative 9.75, 1.5. So POIs is negative 9.75, 1.5. And then this one here, second trace 5, it's between the blue and the black. So I am on the blue line. And there we go, slowly but surely coming up. And then it's enter, cycle through the black one, up or down arrows, it doesn't matter. You're going to get there. And that one is 4.06, 1.5. So that is, these are your corner points right here. Do they match with what? Yeah, it does match. Okay. The answer key is at the bottom there. Okay. So what I've done so far is I've gotten you used to systems because that's what word problems are going to be all about. Okay. So if you want to try these ones, I'm just going to say 35 to 37, I believe. No, a bit further than that. 39. So pick 1 or 2. Some of them are trickier because they have no constant, like the one where you have to pick your second point. Pick 2 and give it a try and time yourselves. See if you can do it in 10 minutes or less. Okay? To be proficient.